And wire candidates, listen to this very important attention. Now, I have a question to solve on the hybridization in carbon atoms of the ethyne molecule, right? Yes, but I want to use it to show you how hybridization occurs, how to form hybridization between in a carbon atom. Now, from there we answer this jam question. But why I am calling out on wire candidates is this is also a typical wire question. You can see it in theory, you can see it in objective. If you see it in theory, how do you defend yourself? So let's go. The question says the hybridization of the carbon atom in ethyne is what? We have sp4, sp3, sp2, sp and s. Only s, right? Let's even know if those things exist and how they occur. Good. Now, first of all, we'll start by what? This is ethyne, right? C2H2, right? If you are to draw it, we draw something like this, right? This is an ethyne. Now, what is hybridization and how do they occur? Hybridization is just the mixing of what? The atomic orbitals of atoms. The atomic orbitals of an atom. That is hybridization. You make the atomic orbitals equal by mixing them together. For example, now in a carbon atom, carbon is what? 6 electrons, right? So this is a carbon atom. To draw the orbital representation, 1s2, 2s2, 2p2. That is 6, right? For a carbon. Good. So if you are to draw this diagrammatically, let us represent this for a carbon. For a ground state electronic configuration of a carbon, this is 1s electron, up and down spin. Now the next energy level now is what? Is 2s electron, up and down spin. Then the next one is what? P. How many lobes? It has 3 lobes, so it is longer. Now 2 up spin, right? So this is 6 electron, 2p. Now for a ground state, carbon. Now, when we subject this carbon now to excitation, when we excite this carbon, so that it can be able to go above the ground state energy level, so we can be able to promote an electron. So this is the first shell, I1s. This is the 2 electrons in it. So the 2s now, after excitation, we only have 1. Only the up spin. The down spin have been promoted to what? The last orbital in the p orbital, which is 2pz, right? Now this is 2pz, this is 2py, this is 2px. Now this is what we now have for a carbon. Now if methane want to form, how methane forms? Methane forms with what? An sp3 hybridization, which is what? If you are to put it in indices, that thing is just like writing in indices. In 2s, no, we are considering only the 2, which is what? The valence shell. It is the valence shell that atoms used to go into bonding. Now, in the s orbital of the second shell, we have only 1 electron. Just like saying s raised to power 1. Now in the p orbital, we have 3. So p raised to power 3. That's how this thing is. Now for a carbon now, once you reach this extent now, what will happen is that since ethyne is what? C2H2, 2 hydrogen are needed, so 2 electrons. So the p orbital will disintegrate into 2 like this. They will disintegrate into 2. Now this is 2py and this is 2pz. They will disintegrate and become what? Unhybridized. Their energy cannot be equated with that of the S2s orbital. Now here, as they are disintegrated, they live here now. They live here, leaving only 2px, which is now hybridized to 2x. This one is what? Unhybridized. So we now have in the 2s orbital we have what? 1 electron. So s raised to power 1. In the p orbital we have what? 1 electron, p raised to power 1. So you know indices tell us to overlook anything 1. So that is why we call them what? SP, right? SP. So the answer is what? Option D. SP hybridization. Now, this SP hybridization will now form between the carbon atoms. We form a single bond called sigma bond, something like this. Sigma bond. These two unhybridized electrons will form a pi bond because they carry pi electrons. They form a pi bond called what? Double bond. So that's why the ethyne have triple bond. These two here is a pi electron like this. Why this singular one in the center is from the hybridized one, the sigma electron. Why this unhybridized form what? A pi bond. So I want to give you a full detail of the bond that is formed in a time molecule. But then the hybridization is what? sp. You know how it is sp? If it is for methane, methane CH4, it will be what? sp3. So all the p electrons will go into the bonding. I hope this is very clear. See you in the next video.